All right, welcome back. Today we're going to see what we can do with a 3-channel video or camera switcher if we're not switching cameras, but servos and ESCs. So in common use, we can use these to switch between 2 or 3 cameras, typically used on FPV aircraft. And you can select via this input that is both powering the electronics and taking a servo signal to then select which of the 3 cameras that you have as potential inputs on this side gets switched through to what is called the output. And in common use, this output goes to your video transmitter for your FPV goggles. And I thought, well, video signal, that's just pulses, and servo signal, that's just pulses. So can we use this electronic piece to switch between servos? And yes, you can, but there are some restrictions. All right, so I already explained this side gets the power and the switching signal. And then on this side, what used to be our video inputs are now our servo outputs. So those are 3 of those 4. And the 4th one, that is the signal coming from the receiver that we want to switch to one of those 3 output devices. And the switching signal is done by this input. All right, so we have a battery, we have an ESC down here, which is both providing power to the receiver via this V cable with a gender changer. I've taken out the signal cable because the signal to the ESC is actually coming from this side of the video switcher. Then we have 1 channel from the receiver doing the switching, and the other 3 normally inputs to the video switcher, which are now outputs, are taken up by 1 servo, another servo, and the ESC via the other half of the V cable. And here I've taken out the red lead, so it is not supplying power to this. The power into this needs to come from this side. If you connect the power to this side, as far as I can tell, nothing happens. But if you have a different voltage here than what you're connecting there, I don't know what happens. Maybe nothing. Maybe one of the voltage regulators will get overloaded. So I'm keeping it safe. This is the power supply that gets switched to the 3 outputs, and therefore needs to be able to provide enough current for whatever you're switching to. All right, so the setup on the radio is pretty straightforward. I have 1 channel that does the movement and another channel that does the switching. Now you might say, okay, I need 2 channels to control 3 servos, but I can't use them at the same time. Is this useful? If you're doing, cranes, earth-moving equipment, functions on a boat or ship, that might be useful because you don't have unlimited number of nice proportional sticks, but you typically have quite a few switches that you can use to control which of those outputs is active. So I set up this switch here to control this channel, which you can see here. And depending where I am, this servo stick moves either our ESC or this servo or this servo. Yeah, so far so good. The first problem is if we go back to our ESC, you can hear that it powers up. So I'm in the servo mode, and now I'm being quiet. Did you hear that? This ESC, or rather this ESC controlling this motor, when it's not active, it does not get the signal it needs to stay active, to not switch off basically. That might be a problem for you, or it might not be a problem. Also what I noticed, so the ESC is now active. So what is happening to the other 2 servos? Well, this servo is powered up. I can't move it. You might hear the motor trying to fight my hand. But this servo is not powered up. And I have no idea why. Obviously, different servos have different ways how they deal with the pulses that coming in. Some are more resilient against slight deviations that the video switcher probably introduces. But both of those servos work. So they just work differently. But there are also servos, pretty decent servos, like this one, or this one, which do not work at all. So if I take out the ESC and put one of those servos in, being mindful of the right polarity, which is thankfully written on the circuit board. So that motor is now no longer connected, but this servo should be connected. And we can see nothing happens whatsoever. This servo still works, and so does this. But the very same input that worked fine with the ESC does not work with this servo. All right, to show it's not the port's fault, I can switch in a different servo. So this very basic servo works just fine. So overall, pretty successful. It's a very cheap piece of electronics that might be able to solve a problem that would be otherwise quite complicated to solve. But it doesn't work for all the servos that I have tested. So I will try to find out why, and see you in that part of the video. All right, so we saw that some servos are entirely fine with the signal coming out of the video switcher and others won't work at all. So let's investigate what is going on. Let's first look at the shape of the pulse train. You can see that we run this, it looks fine. We have a frequency of 50 Hertz. That is what we would want. And if I zoom in, so the neutral position should be 1.5 milliseconds. It's at 1.7, so a little bit off. The lowest position should arguably be at 1 milliseconds. So again, 0.1 of a millisecond higher. And then the top end should probably be at 2 milliseconds, and we're 2.3. So the whole range seems to be shifted upwards by 0.15 of the standard. But I'm pretty sure that most servos will be fine distinguishing what is going on in the pulse width pulse. So if it's not the pulse length or the duty cycle ratio, then it must be the voltage. And so what we see here is that the supply coming from the receiver is not actually at 5 volts, which is the supply, it's at 3.5 volts. But the problem is that the output signal is only 2.8. So that is very low, and obviously too low for some of the servos to work with. So that is the reason why some servos won't work with the video switcher, and others who are able to, reliably determine the pulse length of a 2.8 volt pulse, they will be entirely fine. So if you have a way to determine in which category your servo is, you will be able to predict whether or not it will work on the video switcher. ESCs have their own power supply, even if you don't use it to power the receiver, which might make them more resilient against this. So I have now connected my pocket scope to the pulses that are going to the ESC from the video switcher on one channel, and the other channel is not connected to anything, so that could be a servo. In yellow, that's the signal that is the servo signal that is going to the ESC that is also powering everything. And we can see that that voltage is 5 volts. So that's interesting in the sense that what's coming out of the receiver and what is coming out of the switcher should be 3.5 volts. But I assume because of ESCs having basically their own power supply, that pulse is actually at a level of whatever the power supply internally for the ESC is, and that's 5 volts. If I switch over to the not connected other channel, then we can see the blue curve only having 3 volts. That will then cause problems with some servos if they are connected. All right, so I tried different ESCs, such as this CTI Thor, and which works just fine and gives out 5 volt pulses. And then I switched in this ESC, which only puts out 3 volt pulses, so very low, but works just fine. So 3 ESCs, 5 or so servos that I tested. Half of the servos didn't work, half worked. From the ESCs, all 3 that I tested worked. So very low numbers, but it seems that maybe ESCs are more resilient when it comes to the pulse height that happens with the video switcher. And hopefully this video was helpful for you if you're looking for a solution like this. And let me know in the comments which servos or ESCs you've tried and which are working and which are not. Thank you very much, and until next time.